first parts of this video are going to be things that I already talked about in my notes on 18.1, and this relates to our 18.2. Basically, this is a summary of the things we should know by the time we finish the unit circle project. Here we go. Let's start with degrees, and all these parentheses on the outside, that's because eventually we're going to do the coordinates. Degrees. We're going to start with 0 degrees, and we know that the whole circle is 360 degrees. Those are the same thing. And that means a half circle is 180 degrees. Half of 180 is 90 degrees. So if I was to work my way around the circle, I could say 0 degrees plus 90 degrees plus 90 degrees is 180 plus 90 degrees gives me 270 degrees down here on the bottom. Okay. Then I'm going to think about each of those sections cut in half. I'm going to think about 90 divided by 2 is 45. So I'm going to say 0 degrees, 45 degrees, plus 45 degrees takes me to 90 degrees at the top, plus 45 degrees takes me to 135 degrees, plus 45 degrees takes me to 180 on the left, plus 45 degrees takes me to 225 degrees, plus 45 degrees takes me to 270 degrees on the bottom, plus 45 degrees takes me to 315 degrees, plus 45 degrees takes me back to 360 at the end. Now let's take our 90 degree section and cut it into 3 parts, which is 30 degrees each. So 0 degrees in the beginning. Remember that is always our starting place. Plus 30 degrees, plus 30 degrees makes 60 degrees, plus 30 degrees takes me to 90, plus 30 degrees takes me to 120 degrees, plus 30 degrees takes me to 150 degrees, plus 30 degrees takes me to 180, plus 30 degrees takes me to 210 degrees, plus 30 degrees takes me to 240 degrees, plus 30 degrees takes me to 270 at the bottom, plus 30 degrees takes me to 300 degrees, plus 30 degrees takes me to 330 degrees, plus 30 degrees takes me to 360 degrees. I think most of us can do that okay. I'm going to go to the next page and just show you a slightly different way to do degrees. Different way to do the degrees, and I'm just going to do all one color so I can do it quickly. 0, big gap, add 30, little gap, add 15, little gap, add 15, oops, I'm sorry, that's 45, add 15, big gap, add 30, big gap, add 30, little gap, add 15, little gap, add 15, big gap, add 30, big gap, add 30, big gap, little gap, add 15, little gap, add 15, big gap, add 30, big gap, add 30, little gap, add 15, little gap, add 15, big gap, add 30. And if that doesn't end up with 0, 180, and 360 where you know they should be, then you know you've got troubles. Okay, let's go back and talk radians. I'll talk 2 ways to do radians also. For the radians, I need to start with thinking about 0 radians. Full circle is 2 pi radians. Half of 2 pi is pi. We've done a lot of these when we were drawing angles, where instead of writing down pi, we wrote 7 pi over 7 or 12 pi over 12 or something like that. Half of pi should be pi over 2. So we have, starting back to the beginning, we have 0. We have 1/2 of pi. On the left we have 2/2 of pi, but that just reduces to 1. We have 3/2 of pi. And we have 4/2 of pi, which reduces down to the 2 pi I want, so I don't need to worry about it. Then, just like I did with the radians, I'm going to start by taking the space and cutting it in half. I'm going to say pi over 2. What is 1/2 of that? It would be pi over 4. So that in the center, where the other red one was, I'm going to do another red one that says pi over 4. 1/4 of pi. 2/4 of pi, which is just pi over 2. 3/4 of pi. 4/4 of pi, which is just plain pi. 5/4 of pi. 6/4 of pi, which reduces down to 3/2. 7/4 of pi. And 8/4 of pi, which just reduces down to 2 pi. There's all the red ones. Those are equivalent to my 45-degree angle. So what if I do the same thing that I did with the degrees and say, take my quadrant, which was 90, but now it's pi over 2, and say, what's 1/3 of that space? 1/3 of that space would be pi over 6. So I'm going to start with pi over 6. There's 1/6 of pi. The next one I want to look at is 2/6 of pi, but 2/6 of pi reduces down to pi over 3, so I don't need that. Then I think about 3/6 of pi, which reduces to pi over 2, so I don't need to keep that. And then I think about 4/6 of pi, which reduces down to 2 pi over 3, so I don't need that. Then I need 5/6 of pi. That won't reduce, so I'll put it down the way it is. Then I need 6/6 of pi. Oops, 6/6 of pi. And 6/6 of pi is just the same as pi, so I don't need that. And then I need 7/6 of pi. That doesn't reduce. Then I need 8/6 of pi, which reduces down to 4 pi over 3, so I don't need that. That was 8/6, so then I need 9/6 of pi, which reduces down to 3/2, so I don't need that one. I need 10/6 of pi, which reduces down to 5 pi over 3. And I need 11/6 of pi, which doesn't reduce. And then 12/6 of pi, which reduces down to 2. So there's all my radian measurements. I'm going to go to the next page and show you a different way to think about the radian measurements. And again, I'm just going to do this in black instead of colors, so we can just go through it quickly. I know that, let me go one more page over. I don't know where I put it, never mind. I'm going to start with The bottoms of these fractions are 2, 3, 4, and 6. I'm going to start at the top and say the bottom of the fraction is 2, 3, 4, and 6. Over here, at the top, 2, 3, 4, and 6. Go to the bottom, same thing. 2, 3, 4, and 6. At the bottom, 2, 3, 4, and 6. Every one of these has a pi on top of it. Pause so I could get all those pi's drawn quickly. In the first quadrant, this is quadrant 1. In quadrant 1, the top of all those radian measurements is just plain pi. Over here in quadrant 2, I'm going to say, if I take the bottom minus 1, I get the top. So 3 minus 1, 2. 4 minus 1, 3. 6 minus 1, 5. In quadrant 3, and this one is quadrant 3, I'm going to say the bottom plus 1 equals the top. So 6 plus 1 is 7. 4 plus 1 is 5. 3 plus 1 is 4. And then it gets a little trickier in the last section, but this is quadrant 4. In quadrant 4, I'm going to say the bottom times 2 minus 1 equals the top. 2 times 3 is 6, minus 1 is 5. 2 times 4 is 8, minus 1 is 7. 2 times 6 is 12, minus 1 is 11. Now, if you have to memorize the unit circle, which in Integrated Math 3, we usually have a quiz where you have to memorize the unit circle. For some people, those tricks work easier than trying to work it out a little bit at a time. Always your choice which way you like it better. Then I got to think about all these coordinates on the outside edge. We're going to have to figure those out because those are how we figure out sine, cosine, and tangent. Okay. So suppose we had special right triangles. That means 30, 60, 90, 45, 45, 90 triangles. And we wanted to figure out the sides if the hypotenuse was 1. And the reason we're going to do hypotenuse is 1 is because we're doing what is called a unit circle. And a unit circle means the radius of the circle is 1. We're going to lay these triangles on our circle so that the 1 is the radius. Transfer. I should just put radius equals on the end of the part which says hypotenuse. So I'm going to look at my 45, 45, 90 triangle. And I remember that for a 45, 45, 90 triangle, I know that looks kind of orange. It looked redder when I was doing it in Microsoft Word before I wrote it in here. In a 45, 45, 90 triangle, and we're going to assume these are all 45, 90 degree angles because this doesn't work for us if they aren't. I just couldn't seem to make Microsoft Word draw that for me. So, in a 45, 45, 90 triangle, I have 2 matching legs that are the same size, and I have a hypotenuse that is the short leg times root 2, or the only leg, the size leg there is times root 2. So I'm going to look at this triangle, and I'm going to say, if this 1 is my hypotenuse, I can write n root 2 equals 1. And I want to try to get my n by itself. I'll divide by root 2 on both sides. So those cancel out. And I have n equals. But I don't want to leave my root in the radical. So I'm going to, my radical in the denominator. Divide times root 2 times root 2. So that I end up with root 2 over 2. That's going to be this leg, and it's going to be this leg. The others are both 30, 60, 90 triangles, but I'll work one and then I'll put it on the other one. So if I have a 30, 60, 90 triangle, the basic pattern for a 30, 60, 90 triangle is the shortest leg is opposite from 30, and we call that just n. The longest leg is, we'll say the hypotenuse, the longest side, is 2n. And the one that's opposite from 30, that's not my 30, that's my 60. The one that's opposite from 60 is n root 3. So in this case, I'm looking at a triangle where the 2n side is 1. So if I have 2n equals 1, and I want to get the n by itself, I will find out that my n side is 1/2. So in this picture, the side that's opposite from 30, the shortest side, should be 1/2. And then my long side should be, the long leg should be the n times root 3. So it should be this 1/2 times root 3, which is just root 3 over 2. That means that this side is root 3 over 2. That's actually the same triangle that I have sitting beside it, except that hypotenuse is still 1. The short leg is opposite from the 30, so the short leg is 1/2, and the long leg, root 3 over 2. Remember, when I talk about leg, we're talking about not the hypotenuse, but the two pieces that come together to form the right angle. Okay. I'm going to take those special right triangles, and I'm going to kind of lay them on top of my unit circle so I can use them to figure out the coordinates of all my points at the ends of my radii. This one, I put all the 45-degree angles together. Okay, so I just copied my measurements I got from that red triangle on the other side. Basically, we said both legs are root 2 over 2, and the hypotenuse is 1. This is a unit circle. Notice that I put 1, 0 out here, because if I went out to the edge here, it'd be a distance of 1, because every radius on here is a 1. So that's 1, 0. And then I got here, if I look at this piece, how long is it? Root 2 over 2. That's my sideways, my x distance. And then how far is it upside? Also root 2 over 2. If I look at this one over here, same lengths. Root 2 over 2, root 2 over 2. Down here, how far in the x direction? Root 2 over 2. How far in the y direction? Root 2 over 2. Fourth triangle, how far in the x direction? Root 2 over 2. Root 2 over 2. But we know that when you look at things on the x and y coordinates, you got some positives and some negatives going on. So let me just think. If I just had normal xy coordinates here, and I said, I'm going to go out here 1, 1, 1, 1. Some of those would be negative ones, wouldn't they? So I would be going positive 1, up 0. Positive 1, up, but 0 sideways. basically, if I chose a point out here, anywhere in my quadrant 1, that one would have a positive x value and it would have a positive y value. Let's put those up here. Quadrant 1 always has a positive x value and a positive y value. Quadrant 2, however, I'm going left on my x's, so I'd have a negative x, but I'd still have positive y because my y's are still going up. If I look at quadrant 3, my x's are going left, so they're negative. My y's are going down, so they're also negative. If I look at my last section here, quadrant 4, I have my x's going positive to the right, and my y's going negative because they're down. It will help you if you memorize those things, because once I put in all those little root 2 over 2 things, I still need to think about what's positive and what's negative. So I'm going to throw some negative signs on the x section. And in fact, while I'm at it, I'm going to put it on the x section for the ones I haven't even done yet. All the x's will be negative. In this section, x's and y's both will be negative. Negative on my x and negative on my y. I have seen people put them out here because it just doesn't fit. Well, guess what? That's not the same thing when it's outside the parentheses. Over in this section, I need positive x's, but I need negative on my y's. If you look at the borderline numbers, both this and this have negatives on their y's. This has negative y's. One of these has a negative x, one of these has a positive x. That's okay. We have that middle piece. We have a 0 that's neither positive nor negative. That's also true when we look at borderlines over here. Over here I'm supposed to have negative x's and I'm supposed to have negative x's. Got that. Up here I'm supposed to have positive y's and negative y's. That's okay. We have 0, which is neither. Okay. I think I erased one too many things. Let's put that negative sign back down here. Those are the 45-degree angles. Let's look at the next page. Those are sometimes called bow tie angles because they match each other. I always do them in the same color when I'm making my unit circle. Okay, not always. I did one that was all black. Because they have the same reference angle. You can see that each of those is 45 degrees from the x-axis. It doesn't matter what the number is, 135 or 225. It still is 45 degrees from the x-axis. Here's my green bow tie angles. All of these have a 30-degree angle right here. But one says 30, one says 150, but it's still 30 inside. It's still 30 inside, and it's still 30 inside. We just don't usually write those down because we have these other numbers to look at. Okay, I copied my numbers from my 30, 60, 90 triangle from 2 pages back. For each of these coordinates, I'm going to look at what's the x distance, root 3 over 2, and what's the y distance, 1/2. And I'm going to go around the circle and do that for all these points. But we have to think again about positive and negative. In quadrant 1, everything's positive. In quadrant 3, because that's the next easiest one, everything's negative. So I'll have to put a negative on my root 3 over 2 and a negative on my 1/2. In quadrant 2 up here, my x's are going left, so my x's are negative, but my y's are still going up, so they're positive. So in this section, I need a negative just on the x value. And this, of course, is the opposite from that. In quadrant 4, I have x is going to the right, so that's positive. Y is going down, so that's negative. So my x's are positive, and my y's are negative, so I have to throw a negative. Those are all the angles that have a 30-degree reference angle. 150 degrees is 30 degrees away from 180. 210 degrees, 30 degrees away from 180. You could subtract to find that out. 330 degrees, 30 degrees away from 360. Again, you can subtract to figure that out. We have one more set to do. These are my blue bow tie angles. Put them together, they form a bow tie. Or at least some interesting stacked triangles. Here's my picture for my 30, 60, 90 triangle with the 60 at the base. You always have to think of these as a triangle with the right angle on the x-axis to make them make sense. And this is my 60-degree angle. And each one of these, the 120, the 240, the 300, and the 60, all have 60-degree reference angles because they're 60 degrees away from the x-axis. So again, I'm going to think, how far in the x direction? Part of me just says, there's only two possibilities, 1/2 or √3/2. Is that the long way or the short way? The short way is the x-axis. So I'm going to put 1/2. And then up and down, I get my √3/2. Every box here goes 1/2 √3/2. All of these that hit with the blues. 1/2 √3/2. And sometimes when I'm doing these for myself, just like I did on that first page there, I might fill in, like I did on this page, I might just fill in all the signs before I start filling in the numbers, just so I know that I have them. Okay. Think again about positives and negatives. I'm not going to write it down for every quadrant this time. Quadrant 1, everything positive. Quadrant 3, everything negative. You can make negatives on all these if you didn't have the rest done yet. Over in quadrant 2, my x's are going to the left, so they're going negative, but my y's are still going up to be positive. So I need 1/2 to be negative, but √3/2 is positive. Over here, √4, reversed. The x's are going back in the positive direction. The y's are going down in the negative direction, so I get a negative on my √3/2. Okay, let's look at all of those together now. This is an example of all of those together. You can now use all of those things to figure out sine, cosine, and tangent. For now, let me just tell you that the coordinates go like this. Cosine theta, sine theta. In my 18.2 C notes, I talk in more detail about why this is. But if somebody asks you to find the sine of pi over 6, you would look at pi over 6 and say sine is the y part. My answer is 1/2. If somebody asks you to find the cosine of 5 pi over 4, you would say cosine is the x, so at 5 pi over 4, the x value is negative √2/2. If somebody asks you to find the sine of 330 degrees, you would say sine is the y value at 330 degrees, negative 1/2. Somebody wanted you to find the cosine of 5 pi over 6, you'd say cosine is x, 5 pi over 6, negative √3/2. You will have at least a homework quiz where you have to be able to look at your unit circle and figure those things out. You're going to need to know how to do all those things for the 18.2 C assignment, the trig megatable. But for for now, that's enough. We have regular notes on this chapter, but I just thought it was easier to see this by itself.